Okay, let's get into it. Number 10. Odd radio circles. In 2020, a radio telescope in the Australian outback was quietly mapping the sky, and it found a ring. A perfect circle of radio light, hanging in deep space, with nothing obvious inside it and no reason to be there. And it was big. Not planet big, not star big. Bigger than an entire galaxy. If your eyes could see radio waves, it would sit in the night sky like a smoke ring blown by something the size of the Milky Way. They called them odd radio circles, which, honestly, respect for just describing exactly what they were looking at. ORCs, for short. The telescope was ASCAP, run by Australia's National Science Agency, and in that first survey, it turned up 3 of these rings. Since then, a handful more have shown up. And here's the first strange thing about them. You cannot see them in visible light. Not in infrared. Not in X-rays. Only radio. You could point an ordinary telescope straight at one, stare for 100 years, and never know that a circle wider than a galaxy was floating right there in the dark. So what are they? When the discovery came out, the early guesses were all over the map. Shockwaves from galaxies. Blast waves from a pair of supermassive black holes crashing together. Leftover bubbles from some ancient explosion. And a few people, quietly, at the far edge of speculation, wondered out loud about the throats of wormholes. That one didn't stick. The best guess now is that they're enormous shells of shocked gas. A titanic burst of wind blown out of a galaxy at the center of the ring, expanding into a near-perfect sphere that we happen to see edge on, so it looks like a circle. Probably. That's the best answer we have. But every so often a new one turns up that doesn't quite fit the story, and the astronomers who study them are careful to say the case isn't closed. A ring of light, bigger than everything, that only exists in a color our eyes were never built to see. Space is full of things that aren't hiding. They're just standing somewhere we forgot to look. Number 9. The Pioneer Anomaly. 2 little spacecraft, launched in the early 1970s, flew past Jupiter, past Saturn, and just kept going, out toward the edge of the solar system, in the black beyond it. Pioneer 10 and Pioneer 11. And as they got farther and farther out, into the deep cold, something started to go wrong with the math. They were slowing down. Just a little. A tiny, stubborn tug pulling them back toward the sun, on top of everything gravity was already doing. We're talking about an acceleration of roughly 8 times 10 to the minus 10 meters per second squared, which is a nightmare to say, and basically means 1/10 billionth of the gravity you feel standing on the ground. Almost nothing. But it was there, year after year, and it would not go away. John Anderson and his colleagues reported it in 1998, and it got a name, the Pioneer Anomaly. And for a while, this was one of the most exciting little numbers in physics. Because when a spacecraft won't move the way Newton and Einstein say it should, you start to wonder, is there extra matter out there we can't see? Is gravity itself different at the edge of the solar system? Whole papers got written. Was this the crack in the theory of everything? A message from 20 billion kilometers away, telling us that our laws were incomplete? Here's the answer. In 2012, a team led by Slava Turishev went back through the old data and modeled something everyone had underestimated. Heat. Each Pioneer carried a plutonium power source, pumping out a couple thousand watts of warmth, and that heat radiated off the spacecraft unevenly, a little more in one direction than the other, and light and heat carry a tiny push. Add up that gentle, lopsided glow over years and years, and it was enough. It was exactly enough. The probes had been pushing themselves the whole time, with their own body heat. Mystery solved. And I love this one, precisely because it's the opposite of scary. For 30 years, the universe seemed to be whispering that Einstein was wrong. And when we finally leaned in close enough to hear it, the whisper turned out to be the spacecraft breathing. The most unsettling signals aren't always aliens or new physics. Sometimes the call is coming from inside the probe. Number 8. The Flyby Anomaly. Here's a trick every space mission uses. If you want to send a probe out into the solar system, you don't just point it and fire. You fly it past a planet, usually Earth, and let the planet's gravity fling it forward like a slingshot, stealing a little of the planet's motion to pick up speed. It's routine. We've done it dozens of times. The physics is textbook, precise to a hair. Except a few times, the numbers came back wrong. Spacecraft would swing past Earth, and on the way out the tracking data showed they were going just slightly too fast, or slightly too slow. Not much, a few millimeters per second, the width of a couple of grains of sand per second. But we track these probes so precisely that a few millimeters per second screams at you. It shouldn't be there, and nobody could say why. Galileo showed it. The NEAR probe showed it. Cassini, Rosetta. Several of our most famous missions came around Earth and picked up a phantom nudge on the way past. John Anderson, same name from the Pioneer story, the man seems to collect these, worked out an empirical formula. Plug in the angle the spacecraft came in, and the angle it left, and the formula spits out the anomaly, and it matches 6 different flybys. Which sounds like a solution, until you realize a formula that predicts a thing is not the same as understanding it. The equation reproduces the mystery perfectly. It explains nothing. It's like having a machine that always guesses the right card without ever telling you how. And here's the part that keeps it interesting. Not every flyby shows the effect. Some do, some don't. And the difference between them isn't obvious. People have thrown out ideas. Maybe Earth's spin drags on spacetime a little more than relativity predicts. Maybe there's some unmodeled force. Maybe it's a subtle error in how we account for the atmosphere or the tracking stations. Pick your poison. None of them has clearly won. So, unlike the Pioneer Anomaly, this one is still open. A little signal written into the flight paths of our own spacecraft saying there's something about gravity right here in our backyard that we haven't fully worked out. And every time we swing a probe past home, we listen for it again. Number 7. The Galactic Burper. Down near the center of the galaxy, in the crowded, glowing, dust-choked heart of the Milky Way, something turned on. In the year 2002, a radio telescope caught it, a source that fired off 5 powerful bursts of radio energy, each one lasting about 10 minutes, coming back around on a regular cycle, roughly every 77 minutes. Steady rise, bright peak, fall, rise, peak, fall, like something with a pulse. It got a designation full of numbers and a much better nickname, the Galactic Burper. Now, a repeating radio source isn't automatically weird. Pulsars do that, spinning lighthouse stars sweeping a beam past us. But this didn't fit the pulsar mold. The bursts were too long, the cycle too slow, and when astronomers worked out how bright it truly was, they got a number that's genuinely hard to deal with. The brightness temperature came out around 10 to the 16. That's a 1 with 16 zeros after it, Kelvin. That's not a real temperature of a real surface. Nothing is that hot. What it tells you is that the radio waves aren't coming from something merely glowing. They're being produced by some coherent, organized process, the kind of thing that takes a very specific and extreme physical setup to pull off. People proposed answers. A pulsar wobbling as it spins. A pair of dead neutron stars locked in a tight orbit. Some kind of exotic magnetic star. And the source was seen again a couple of times in the following years. Faint echoes of that first burst pattern. And then, mostly, it went quiet. More than 20 years later, we still can't say for sure what it was. And here's what makes the burper matter more, now than it did then. At the time, it was a one-off oddity. A thing near the galactic center that didn't make sense. But it may have been an early glimpse of a whole hidden category of objects. Slow, repeating radio sources that our surveys were simply too fast blinking to notice. The burper wasn't a fluke. It might have been a warning that the radio sky is full of slow, patient signals, ticking away that we'd been walking right past. Something at the heart of the galaxy cleared its throat 20 years ago, 5 times, and then fell silent. And we never learned its name. Number 6. Gleam X. For decades, there was a rule about spinning dead stars, and the rule was they spin fast. A pulsar, the collapsed, city-sized corpse of a star, whips around in seconds, or fractions of a second, flinging a beam of radio light past us like a strobe. If one slows down too much, the theory said, it switches off. It crosses a line physicists literally call the death line, and it goes dark. It can't make radio waves anymore. That was the rule. In 2022, a team led by Natasha Hurley-Walker, working with a telescope array in Western Australia, found something that broke it. They found a source, buried in old data, that pulsed once every 18 minutes. Not seconds. Minutes. Each pulse a blast of intensely organized radio light, lasting up to a minute, almost perfectly polarized. The mark of a powerful, ordered magnetic field. It would flare and flare again, 18 minutes apart, patient and regular, for about 3 months in early 2018. And then it stopped, went silent, as if it had said whatever it came to say and switched off. Here's why this was so alarming to the people who found it. An object spinning once every 18 minutes is way, way past that death line. By everything we thought we knew, it should be one of the dimmest, deadest things in the sky. Instead, it was, for a few months, one of the brightest radio sources at its frequency in the entire sky. Something was powering it. Something was letting a slow, ancient, supposedly dead object scream in radio light. And the honest answer to what that something is, an ultra-magnetized neutron star pushed past its limits, a strange kind of highly magnetic white dwarf, is that we still argue about it. It doesn't sit at the galactic center. It isn't near anything special. It's just out there, in our galaxy, an object that shouldn't be able to make a sound, keeping perfect time for 3 months and then going quiet. The universe had a rule book, and something out there, calm and bright and impossible, tore a page out of it, and then left before we could ask how. Number 5. The Magnetar's Scream. To understand why this one shook people, I have to back up and tell you about the mystery it walked into. For years, one of the biggest puzzles in astronomy was the fast radio burst. These are flashes of radio energy that last 1,000th of a second, a literal blink. But in that blink, they release as much energy as the sun puts out in days. And they were coming from all over the sky, from galaxies billions of light years away, and we had no idea what made them. Colliding stars, black holes, something we hadn't imagined. The ideas got wild, and yes, some people floated the A word, alien transmitters. Because when something is that powerful, and that brief, and that unexplained, you consider everything. Then, on the 28th of April, 2020, one went off in our own galaxy. The source was a magnetar called SGR 1935 plus 2154. A magnetar being the single most magnetic object in the known universe. Take a dead star, heavier than the sun, crush it into a ball the size of a city, and wrap it in a magnetic field so strong it would scramble the atoms in your body from halfway across a solar system. This one sits about 30,000 light years away, inside the Milky Way. And that day it convulsed and let out a fast radio burst, the first one ever traced to a source inside our own galaxy, and the first ever pinned to an object we could actually name. 2 telescopes caught it at once, and it lined up with a flash of X-rays from the same spot, at the same instant. That was the moment the fast radio burst mystery cracked open. Because here, finally, was proof. At least some of these deep space flashes are magnetars. Dead stars, seizing, screaming in radio and X-ray light. Not aliens, not colliding black holes, corpses with magnetic fields from hell. But sit with what that actually means, because it's a double-edged thing. We spent years watching these bursts arrive from the safe distance of other galaxies, faint and far away, and then one detonated in our own. It was harmless. 30,000 light-years is a long way, but it moved the mystery out of the abstract and into the neighborhood. The screaming isn't just something distant galaxies do. It's something the dead stars of the Milky Way do too. There are magnetars scattered through our galaxy, silent for now, and every so often one of them wakes up and shrieks in a voice we can hear across the whole sky. Number 4, the Clockwork Burst. Let's stay with fast radio bursts, because just as we were getting comfortable calling them magnetars, one of them started keeping a schedule. Most fast radio bursts flash once and never repeat. A few, we learned, do repeat. The same source, firing off burst after burst, randomly, unpredictably. Fine. Strange, but fine. Then, in 2020, the Keim telescope in Canada was watching one particular repeater, a source in a spiral galaxy about 500 million light-years away. And the astronomers noticed something in the timing that made the hair on the back of the neck stand up. The bursts weren't random. They were on a cycle. For about 5 days, the source would be active, spitting out bursts. Then, for roughly 11 days, silence. Then, active again. A rhythm of 16 1/3 days, repeating, over and over. They tracked 38 bursts across a year and a half, and almost every single one arrived inside that same, recurring 5-day window. It was the first time anyone had ever seen a fast radio burst keep time. And this is the thing that makes a scientist deeply uneasy, in a way that's hard to explain to people outside the field. It's not that periodicity proves aliens. It's that periodicity is precisely the fingerprint we've always said would suggest intelligence. A clean, repeating, mathematical cycle. If you're scanning the heavens for a message, regularity is the flag you're looking for. And here was one of the most violent phenomena in the universe. A blast releasing days of the sun's energy in a millisecond, doing it on a calendar. Now, the leading explanation is not a transmitter. It's probably a magnetar locked in orbit around a companion star, so that we only see its bursts when the orbit swings it into view, or when a stellar wind clears out of the way. A cosmic lighthouse with something periodically blocking the beam. Probably. The exact mechanism is still argued over, but that's the quiet horror of the good mysteries. The natural explanation is perfectly reasonable, and it still leaves you staring at a signal from 500 million light-years away that arrives, like clockwork, in a window you can mark on a calendar. Nature can count. And when it counts out loud, it's very hard not to feel like something is trying to be understood. Number 3. Przybylski's star. About 350 light-years from here, there's a star. And when you split its light into a spectrum, the barcode of dark lines that tells you exactly what a star is made of, you get something that should not be possible. Every star is a fingerprint. Burn the light through a prism, read the lines, and you know its ingredients. Hydrogen, helium, a sprinkle of the heavier stuff. Do that for almost any star in the sky, and you get the expected recipe. Do it for this one, Przybylski's star, named for the astronomer who first noticed it was strange back in 1961, and the recipe breaks. The spectrum is crammed with elements that have almost no business being in a star's atmosphere. And not just unusual amounts of ordinary elements. We're talking about the heavy, exotic actinides. Actinium, protactinium, neptunium, plutonium, americium, curium, and elements with names like berkelium, californium, einsteinium. The stuff at the very bottom of the periodic table. The stuff we make in nuclear reactors and bomb tests. But here's the line that turns this from weird into genuinely disturbing. The spectrum also shows promethium and technetium. These are radioactive elements with short lifetimes. Promethium's longest-lived form has a half-life of under 18 years. 18 years. That means if you had a pile of it, in less than 2 decades, half of it is gone, decayed away into something else. So for that element to be sitting in this star's atmosphere right now, shining its lines into our telescopes, it cannot have been there since the star was born. It would have vanished eons ago. Something has to be making it, continuously, now, and nobody knows what. The mainstream explanations are strange enough on their own. Maybe the star's ferocious magnetic field is accelerating particles that slam into the atmosphere and cook up these elements. Maybe there's a hidden neutron star companion, quietly seeding it. Maybe, and this is the exotic one, we're seeing the decay products of undiscovered super-heavy elements from a predicted zone of the periodic table called the Island of Stability. Elements we've never made and can't yet even name. And then, out at the very fringe, there's the idea that Carl Sagan-adjacent thinkers have raised and quickly set aside, that a star spectrum is a place an advanced civilization could, in principle, hide a signal. Or dump the waste of unimaginable industry. Nobody serious is claiming that's what this is, but the fact that it comes up at all tells you how far outside the normal this star sits. 60-some years since we noticed it, and Przybylski's star is still writing in a chemistry we can't read. A message in impossible light, 350 light-years away, refreshing itself faster than it should be able to. And we are still standing at the bottom of the page, sounding out letters, with no idea what the sentence says. Number 2. The edges signal. This one is a signal from the beginning of everything, and it came in too loud. Go back to the cosmic dawn. The moment, a couple 100 million years after the Big Bang, when the very first stars ignited and the universe, which had been dark, lit up for the first time. That first starlight left a mark. It reached out and touched the vast clouds of hydrogen gas filling the young cosmos, and changed how that hydrogen absorbed the background radiation at one very specific radio wavelength. That mark has been stretching and traveling toward us ever since. Catch it, and you're hearing the birth cry of the first stars that ever existed. It is one of the faintest, most sought-after signals in all of astronomy. In 2018, a small, humble radio antenna sitting in the Australian desert. An experiment called EDGES, not a giant dish, just a tabletop-sized instrument on the ground, reported that it had caught it. A dip in the radio background, at exactly the wavelength you'd expect, from exactly the right era. The first fingerprint of cosmic dawn. That alone would have been a landmark. But the signal was wrong. It was too deep. Roughly twice as strong as it was physically allowed to be. The depth of that dip tells you how cold the primordial hydrogen was, and the hydrogen appeared to be far colder than the coldest temperature the standard picture of the universe permits. It's as if you measured the temperature of a pot of water cooling on a counter and found it had somehow dropped below the temperature of the room around it. That's not supposed to happen. Something had to be pulling heat out of the early universe. And the leading explanation is the one that should raise the hair on your arms. Dark matter. The idea is that the ordinary hydrogen was losing its heat to the dark matter, that the two were quietly, gently touching, trading warmth, through some interaction beyond gravity, that we have never observed anywhere else. If that's true, then this faint dip from the dawn of time would be the first whisper of dark matter doing something other than pulling. The first time the invisible ever reached out and touched the visible where we could see the mark. I have to be honest with you, because the science demands it. A few years later, another experiment called CERES went looking for the same signal with a different instrument and did not find it. So the EDGES detection is now in doubt. It might be real and revolutionary. It might be an artifact, the ground, the antenna, The messy foreground of our own galaxy fooling a very sensitive machine. We don't yet know. But think about what was on the table for a moment. A signal from the first stars in existence, arriving too loud, and the best explanation we had was that we were overhearing dark matter and ordinary matter touching in the dark, 13 billion years ago. Sometimes the most terrifying message isn't a threat. It's a single number that shouldn't be possible, arriving from the dawn of time, telling you the universe is doing something you have no theory for. Number 1. The 234 stars. Everything on this list so far has had a natural explanation waiting in the wings, even when we couldn't prove it. This last one is different because of what the scientists themselves chose to write down. In 2016, 2 astronomers at a university in Quebec, Hermano Borra and Eric Trottier, did something clever. Borra had published a paper a few years earlier making a prediction. He said, if an alien civilization wanted to signal us, one efficient way would be to fire extremely brief, regular pulses of laser light at us. And he worked out exactly what that would do to the star's light when we recorded its spectrum. It would leave a very specific, very subtle periodic ripple, a mathematical signature you'd never notice by eye, but that would jump out of the right analysis. He predicted the precise shape such a signal would make. Then he and Trottier went looking for that shape. They took the Sloan Digital Sky Survey, a catalog of the spectra of about 2.5 million stars and galaxies, and they ran every one of them through the analysis. And out of 2.5 million objects, they found the signal in 234 stars. And here's what made people sit up. Those 234 stars were not random. They were overwhelmingly stars almost exactly like our sun, the same narrow range of size and temperature, which is precisely, eerily, what you'd expect if the signal were coming from civilizations around sun-like stars. The kind of stars we already suspect are the best homes for life. And in their paper, Borra and Trottier did not hedge into vagueness. They wrote that the signals have exactly the shape of an ETI signal, extraterrestrial intelligence, that Borra had predicted. In a peer-reviewed journal, about 234 specific stars in the sky. Now, the reaction was swift and skeptical, and mostly fair. Seth Shostak, one of the most respected voices at the SETI Institute, pointed out the obvious problem. It seems awfully unlikely that 234 separate alien civilizations would all, independently, be beaming us the exact same signal at the exact same time. That's not how you'd expect a galaxy full of independent species to behave. Far more likely, he and others argued, was some subtle artifact, a quirk in how a certain family of spectra had been processed, a ghost in the machine of the analysis. Probably that's what it was. But here's the part that stays with me, and it's why this is number 1. Borra and Trottier anticipated that objection. In the paper, they specifically argued against the boring explanations, showed that the signal appeared in only a tiny, chemically specific slice of stars, that it didn't behave the way an instrumental glitch should, that the brightness pattern was wrong for an artifact. And then the story just faded. Breakthrough. Listen, the big alien hunting project flagged it as worth a look. A few follow-ups happened, and then the whole thing drifted quietly out of the headlines, unresolved. Not debunked, not confirmed, just left there, hanging. So somewhere in the records of the Sloan survey, there are 234 stars, nearly all of them the sun's siblings, all of them flickering with the same faint, precise, predicted pattern. And the most careful thing anyone can honestly say is that we don't fully know why. We looked up, we found the exact shape a message was predicted to make, in the exact kind of stars where we'd hoped to find one. And then we looked away. Maybe it was noise. Maybe it was the machine dreaming. Or maybe, one afternoon in 2016, in a pile of 2.5 million spectra, the answer to the oldest question we have was sitting quietly in the data, keeping time, waiting for someone to be brave enough to say what it looked like out loud. And we glanced at it, and we got scared, and we moved on. The sky is not silent. That's the thing none of these stories will let you forget. It is full of bursts, and rings, and rhythms, and impossible light. Most of it natural, all of it strange, and every so often something that lines up a little too well with what we've always been afraid and hoped to hear. We keep waiting for the universe to send us a message. Maybe the real question was never whether it would. Maybe it's whether, when it finally does, we'll have the nerve to admit what we're looking at. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them. See you in the next one.